MAT 3531 Differential Equations 2 Lesson 3 Partial Differential Equations. First of all, we have to learn some notations. So if we have daba z over daba x, we are normally denoting it as p, and q we are taking as daba z over daba y, and r as daba square z over daba x square for as s, daba square z over daba x times daba y, and as t we are taking daba square z over daba y square. So these are some notations. So if you have daba z over daba x, you can use p. So if you have daba z over daba y, you can use q. These are some standard notations, so you can remember those things. And the first topic of this lesson is derivation of partial differential equations by elimination of arbitrary constants. There are some examples. We can go through these examples. The first one, z equals ax plus by, eliminate a and b. So first you can differentiate partially with respect to x and y. Then you can take if you differentiate with respect to x, then daba z over daba x. So here x is a constant, so here a is a constant, then x, and this one goes to 0, and here remaining only a, right? So then here next we can differentiate with respect to y, then daba z over daba y, then here this part goes to 0 and this is a constant, then b, right? So then now you found you have to eliminate elimination of arbitrary constant. So you have to eliminate this a and b. So now you found a and b, then you can write, therefore z equals, instead of a you can write daba z over daba x, right? So daba z over daba x times x plus, instead of b you can write daba z over daba y times y. This is the answer. So then the second example, z equals a times e to the power minus b square t cos bx, eliminate a and b. So here also you can differentiate with respect to x and y. First I'm going, so x and here only, not y, x and t. There are two variables here, t and x. So I am going to first differentiate with respect to x, then I can write daba z over daba x. If you take daba z over daba x, then a is a constant, so you can write a as it is. Then here t is also a constant, so you can write that part also as it is. And cos bx, cos means if you differentiate, that is minus sine bx times bx. If you can differentiate, then it's come as b. So you can take daba z over daba x equals minus a b e to the power minus b square t sine bx, right? So I am taking this as first equation. Then now I can differentiate this same equation with respect to t. Then I can take daba z over daba t equals, then here a is again constant, then now cos bx is also constant, right? Then cos bx constant. Now I have differentiate only this part, if you differentiate E, you can take the same answer. Then I am writing this again. Then I have to differentiate this part. Then B is a constant, then it's come as minus B square. Then da by Z over da by T I can take as here minus AB square minus AB square times e to the power minus B square T cos bx. That is second equation. Right, now I can differentiate first equation again. Then by 1 I can write da by square Z over da by x square. I am differentiate again. Then here with respect to x, then minus AB E, these are constant, B to the power 2 T, then sin bx, if we differentiate that, it come as cos bx multiplied by B again. Then you can take this as minus AB squared E to the power minus B square T cos bx. This is the third equation. So now you can see this is minus AB square e to the power minus B square T cos bx, and the second equation also same. So therefore you can equal second and third equations. So then you can take the final answer as d square z over dx square equals 4 dz over da by z over da by t. This is the answer, right? Then third equation, third example, z equals a times x plus y plus b. So again we can partially differentiate with respect to x and y. So I am first differentiate with respect to x, then da by z over da by x. So is a constant, then here 1 plus 0, then this is also a constant, then it come as a. Then I can differentiate with respect to y also, then a is a constant, 0 with respect to y, this is also 0, again it come as a. Then easily we can write, therefore da by z over da by x equals da by z over da by y. This is a way of solving the partial differential equations by eliminating the arbitrary constants. Then next one, simultaneous equations of the form dx over p equals dy over q equals dz over r. There are three rules we are going to learn according to the simultaneous equations of this format. The first rule is solution of dx over p equals dy over q equals dz over r when one of the variable is absent or cancels out from the two of the fractions. So then in that case how we can take we will see how we can take the answers for those partial differential equation through example. So this is the example 1. Then here x over y square z dx equals dy over z equals dz over y square. So to solve this equation, so you have to take pairwise those terms. So first we can consider x over these two, x over y square z dx equals dy over z. Then z is common, we can cancel, then it's come x times dx equals y square dy. We can integrate, so integrate both sides, so we can integrate. Then here come x square over 2, here y cube over 3 plus c1, where this is an arbitrary constant. So now you can consider these two, right? Then dy over z equals dz over y. So then we can take this side, then y square over dy equals, then again we can z times dz, again we can integrate, then it's come y cube over 3 equals z square over 2 plus c2, where c2 is a arbitrary constant. Then we can subject c1 here, then it is x square over 2 subtraction x cube over 3, this one, and c2 also we can subject, then y cube over 3 subtraction z over 2. Then then the general solution we can write phi c1 comma c2 equals 0, where phi is a arbitrary function, right? So then c1 we can take y cube over 3, sorry, x square over 2 subtraction y cube over, here y cube, no, here y cube over, sorry, what is it, y square, yeah, x square, right, y cube over 3, right, x square over 2 subtraction y cube over 3, then comma, then this one y cube over 3 subtraction z square over 2 equals 0, where phi is, you have to write that also, where phi is is an arbitrary function. Phi should be a arbitrary function, right? Then the second example, dx equals dy equals dz, right? So you have to consider first d2, then dx equals dy, then you can integrate, then it's come x equals x, here y plus c1, c is arbitrary constant, then you can subject c1 is subtract c1, you can take x minus y, right? Then again you can consider dy equals dz, then y equals z, then z you can take like this way, then you can write the general solution, phi equal how we can write phi c1 means x minus y comma c2 y minus z equals 0. You can write where these two c1 and c2 are arbitrary constants also, and phi is an arbitrary function, right? So this is the answer for this example. Then there is a note, method of solution for Lagrange method. Then working rule for this form of equation, p times p plus q equals r. So we can consider this through an example. Then this example 3, a times p plus q equals z. Then so you can use this way, this equation, what is this, p first we can simplify this, then we can take this way, p plus q equals r, then a equals p, then q equals a, p equals a, q equals a, and r equals z. So then again you can write the general form of the equation, that is according to this way, sorry, this method, according to this method you can write general form is dx over p equals dy over q equals dz over r. Now p equals a, q equals a, and r equals z. Now you can consider pairwise. Here dx over a equals dy, then you can cancel a, then you can integrate, then x equals y plus c1, where c is an arbitrary constant. Now you can consider these two, right? Then it's come dy over a equals dz over z, right? So then you can take a for that side, then dy equals a times, you can write this in here this way, a times 1 over z times dz, then 1 over z means that is ln z, no? So we can integrate both sides, then here it's come y a times 1 over z dz means ln z, and c2, where c2 is the arbitrary constant, then you can subject the c2 also. Then you can write the general solution 5 times c1 c2, c1 is equals x minus y, then c2 is equals y subtraction a times ln z equals 0, where c1 and c2 are arbitrary constant and phi being an arbitrary function. Then rule 2, one integral is known by the rule 1. You can find one integral from rule 1 and use that integral to obtain the second integral. So find in one integral, then you can use that integral to find the second integral, right? Then this is the example, dx over 1 equals dy over 3 dz over 5z plus tan y minus 3x. First we can consider this one, dx over 1 equals dy over 3. So then you can send 3 for that side, then you can integrate both sides, then come integrate both sides, then here comes 3x plus, sorry, equals y plus c1, this one, where c is c1 is arbitrary constant, then you can subject c1 as 3x minus y. Then then consider this part as c2, right? We'll take y subtraction 3x as we can find this part with, if you change this side, y minus 3x, that is we can take as c1, right? So then we can substitute for here, again this we can take c1, then 5z over tan c1, then, right? Here again equation reduced to that form. Then now we can consider this two, then dx equals dz over 5z over tan c1. So then we can integrate this part, then for integrate this, so first we can 1 over 5 there and multiply this by 5, then differentiation of this part is in there, so we can write this as ln. Then if we integrate this one, x equals 1 over 5 ln 5z plus tan c1 plus c2, where c2 is an arbitrary constant. So then x equals ln, then instead of c1 we can substitute this part equals c2, then you can find what is c2. Then finally we can write the general solution 5 times uv, u means first c1 is equals y minus 3x minus y, and this part c2 you can write this equation. So this is the answer, where phi being an arbitrary constant. Then the second equation, second example, solve x zp, y zq and xy. So then first we can do this as p and this as q and this as r according to this general form of the equation. So p equals xz, q equals yz, r equals xy. Then we can write dx over p, dy over q, dz over r. Then dxp equals xz, dq equals yz, and r equals xy. Then we can consider the pairwise. First we can consider these two, dx over z, dy over z, then z and z cancel, then 1 over y, 1 over x, then ln x equals ln y equals ln cy, where c1 is an arbitrary constant. So then ln cy you can subject, then we can send for this side, then ln x subtraction ln y equals ln c1. Then you can write this as ln x over y equals ln c1, then c1 equals x over y. You can subject x, you can find x equals c1 times y. Now you can consider the other pair, dy over yz equals dz over xy. So y you can cancel those y, and dy over z equals dz over x, but you found x equals c1 times y. Then we can substitute instead of x, here you can write c1 over y. Then c1 times y equals z times dz. Then c1, if you can integrate this, y square over 2 times z square over 2, then plus c2, then you can send for that side. Then c2 is equals c1 times y square over 2 subtraction z square over 2. Then instead of c1 you can write x over y, then here you can write x over y, then here you can write x over y, then this y and this y cancel, then here coming xy over 2 subtraction z square over 2 equals c2. Therefore you can write the general solution here. What is the general solution? 5 times c1 you found x over y, comma, then now here answer is what? xy over 2 subtraction z square over 2 equals 0, where 5 is being an arbitrary function, right? This is the answer for that example. Then rule 3, let p1, q1 and r1 be functions of x, y and z. Then by a well-known principle of algebra, each fraction in dx over p equals dy over q equals dz over r will be equal to, right? So if it is in that form, you can equal to reduces that form, then it means these both are equal. That is equals to p1 dx plus q1 dy plus r1 dz equals p1 p plus q1 q plus r1 r. To solve this equation, so we are separately equals this is for this part for 0 and this part for 0. Then you can get the general solution for the partial differential equations which is in that form. It means that form, then you can reduces for this form and individually equal to 0 for both numerator and denominator. You can take the general solution. Then this is the example. A times dx over b minus c yz equals b dy c minus a zx equals c times dz a minus b xy. Then here multipliers as choosing the multipliers as x y z, because then here according to this equation p1 over p we have to create, no? Then this is in now that form, no? Then this form is here, right? This form is there, then it can be reduces to that form. Then for that first we have to choose as the multiply x y z. So then I am multiplying this and x and divide by x, then no harm for this equation. Here this one multiplied by y, divide by y, no harm. This one multiplied by z, divide by z. Then you can take here ax b minus c x y z, right? Then here by c minus a x y z again times dy. Then here c z a minus b x y z times dz. Now equation is reduces for that form, this form. That's why we are choosing those multipliers as x y z and converted the equation into that form. Now if equation is that form, according to this rule you can write in this way, right? P1 over P. So what is P now? Here then you can write P1 over P. Here P1 over P. Likewise then this form you can write P1 times dx. Now what is P1? P1 is x. P1 is x. Then P1 times dx. So P1 times dx plus, so you can reduce these equations for that form. Then after that you can equal this for 0. Denominator b minus c, that part for 0, and numerator I told you earlier also. Then this part also 0. That is the rule, right? According to the rule you have to equal for this for 0. Then ax times dx by times dy plus cz times dy equals 0. Then you can integrate this separately. This is integration and this part integrate, then this part integrate, then a is constant, then x square over 2 plus y, sorry, b y square over 2 plus c z square over 2, right? So here come it is equals c1, where c is an arbitrary constant. Then you can reduces this multiplied by 2. This is again come as a constant 2c1. Again it is equal to c1. You can if you need you can remain this as c1, or if you need this multiplied by 2c1 you can take another constant. Then ax square plus by square plus cz square equals c1. Now you can another equation down, you can choose another multipliers. So ax, by and cz consider as multipliers. Then p1 equals ax and qy equals by and r1 equals cz. So then again we can write the equation p1 times p, here this equation. Then it is come as this one, a square x equals a times b minus c x y z. Then q1 b square y dy b times c1 c minus x y z equals, again you can write c square z dy times c over c times a minus b x y z. Again this is in that form, so you can write use this equation and write in this form a square x dx, right? This part you can 0 equal to 0. Again now to solve this you can equal this part equal to 0 and this part equal to 0. Then here that is done in there. Then you can integrate, sorry, then you can integrate this one. Then it's come as how, a square x square over 2 plus b square y square over 2 plus c square z square over 2, right? This one. Then you can multiply whole equation by 2. Then here come 2c2. Then again you can change this as c2 as constant. Then a square x square plus b square y square plus c square z square equals c2. Then general solution you can write, you found c1 and c2 where c1 is here and c2 is there. So then the answer is 5 times, general equation is 5 times ax square plus by square plus cz square comma a square x square plus b square y square plus c square z square equals 0, where 5 being an arbitrary function, right? Then the next example, same way, dx over x y square z square equals dy equals y z square x square dz over z x square y square. So choosing x y z as multipliers, then again you can choose x y z as multipliers. Then you can multiply x and divide x. Then here come x square multiplied by y multiplied by z. Then here comes z square, right? Then you can reduces these equations for that form, right? X over z, then x square y z. Likewise you can write this equation. After that, equal this part to 0 and this part to 0. Then you can integrate this, right? Then x square over z, sorry, x square over 2, y square over 2, z square over 2. Then you can find c1 as x square plus y square plus z square. Again you have to choose the multipliers suitable for this one. Then here we can take 1 over x, 1 over y, 1 over z. Then right, then if you take this as multipliers, then you can here 1 over x, right? Then 1 over x times dx plus 1 over y times dy plus 1 over z times dz, right? So 1 over x means, I'll show you how to get this one. Then now choose multipliers as 1 over x. Here I am write 1 over x. Then if I write 1 over x there, this is cancelled. 1 over y, 1 over y times y, this is cancelled. 1 over z, 1 over z times z, this is cancelled. Then what's come? 1 over x dx over this part, 1 over y this part only, this is cancelled, right? Then we can write equation that way. This part added this one. Then separately we can equal these denominator and numerator for 0 as this way. Then after that we can integrate this. So if we integrate this, what happen? So here we have to equals this part for 0, 1 over x dx. Then we can integrate then this integration, this integration, this integration. So this is ln, no? Ln x plus ln y plus ln z equals ln c2. Then we can write ln x y z equals ln c2, then c2 equals x y z. Then you can write the general solution, 5 times x square y square plus z square times x y z equals 0, where 5 being an arbitrary constant. So this is the way of solving the partial differential equations by using these. First we talk about how to eliminate the constant, and second we take this simultaneous equation of the form dx equals p, dy equals q, and dz equals r, and we use 3 rules for solve the problems. I think now you can understand the lesson. So solve these problems again in yourself, and so if you have further problems if you need further clarification according to this lesson, you can contact me. And also there is a tutorial based on this lesson also. First go through these examples and understand the lesson. After that you can do the tutorial. So thank you very much.